morning, children. Today we are going to start with a new topic, least common multiple, or we can say LCM. Earlier you have done the topic highest common factor. That means among the common factors we have to find the highest of them. Now as from the name it is very clear, this is least common multiple or lowest common multiple. That means among the common multiples we have to find the least multiple. Now through an example I am going to explain you how to find the least common multiple of two or more given numbers. The first example that we are going to take is we have to find the least common multiple of 6 and 18. Now this example I am going to do with the help of prime factorization method. We have to do the prime factorization of 6 and 18 using them together. So as the name is prime factorization method, so we are going to use only the prime numbers, and I hope it is clear to you what are prime numbers. So we'll start with the smallest prime, and that is 2. Now in the table of 2 we have 2 3s are 6 and 2 9s are is 18. Now these two numbers 3 and 9 does not go with the table of 2, so we'll start with the next prime, that is 3. 3 1s are 3s are. Now the first number we have approached to 1, but still this 3 is pending, so we'll start with 3 again. 3 1 as it is and 1s are. We are going to proceed with this method until for all the numbers at the end we are going to have 1 1 1 everywhere below the numbers given. So as we have got 1 1 below both the numbers 6 and 18, we are going to stop here, and therefore the LCM will become the multiplication of all the prime factors which are appearing over here. That is 2 into 3 into 3. That is 2 3s are 6 and 6 3s are is 18. Therefore LCM of 6 and 18 is equal to 18. Now coming up to the next example, we have the numbers 24 and 90, and again with the help of the prime factorization method we are going to find its LCM. So we are going to start with the smallest prime, that is 2. 2 12s are and 45s are. Now see children, here 12 goes with the table of 2 but 45 does not. But still we have to go check with the table of 2. 2 6 are and keep 45 as it is it is not a multiple of 2. Then again 2 3s are 45 as it is. Now see here 3 and 45 does not come in the table of 2, so we are going to start with the next prime, that is 3. 3 1s are and 15s are. Then we have reached the 24 as 1, but 15 is still left. So we will again proceed with the table of 3. 3 1s are 5s are. Now you are left with 1 and 5. So we'll start with the next prime, that is 5. 5 1 as it is and 1. Now as you can see, both the numbers we have reached till 1 1, so we are going to stop here. So the answer for LCM will be the multiplication of all the prime factors appearing, irrespective of number of times they are appearing. So we are going to take all the numbers together, that is 2 into 2 into 2 into 3 into 3 into 5. That is 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 3s are 72 and 72 5s are is 360. Therefore the answer for the LCM is 360. Now coming up to the next example, we have 3 numbers now. We have to find the LCM of 3 numbers, 20, 25 and 30. Now let's see how to proceed it. Take the prime factorization method and start with the smallest prime. Children, it's better to start with the smallest prime number, although these numbers comes in the table of 5 also, but it is recommended to you to start with the smallest prime, that is 2. Now 2 tens are 25 as it is and 15s are. Then again 10 is divisible by 2, so we are going to use 2 again. 2 5s are 25, 15 as it is. Now again I am saying although these numbers comes in the table of 5, you can use 5, but still I am using the next prime after 2, that is 3, as the number 15 is divisible by 3. So 3, 5 as it is, 25 as it is and 5. Now you can use the next prime, that is 5, because all the 3 numbers are divisible by 5 now. 5 1s are, 5s are, 1s. Then at the last we have 1, 1 and 1. So the LCM will be, if you multiply all these prime factors, 2 into 2 into 3 into 5 into 5, after multiplication you will see the answer is coming out to be 300. 2 2s are 4, 4 3s are 12, 12 5s are 60 and 65s are is 300. So LCM of the given 3 numbers is 300. Alright, the next example 4 is of 4 numbers. We have to find the LCM of 4 given numbers, 12, 16, 24 and 36. So, which is the smallest prime we are going to start with? Yes, it is 2. So we have 2, 6s are, 8s are, 12s are and 18s are. Then again all these are even numbers, 2, 3s are, 4s are, 6s are and 9s are. Now children, out of these 4 numbers, 4 is still divisible by 2, so we are going to proceed with 2 only. 2, 3 as it is, 2, 3, 6 was also divisible by 2. So now the next step again, 2 is left and it is divisible by 2. So 2, 3 as it is, 1, 3, 9. Now these 4 numbers which are left, 3, 1, 3, 9. We'll start with the next prime number, that is 3. 3 1s are 1, 1 and 3. And lastly with 3 again. 3, 1, 1, 1 and 1. So at the end we are left with all 1s. So the answer for the LCM will be 2 into 2 into 2 into 2. 2 is appearing 4 times and 3 is appearing 2 times. So when you multiply, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 3s are 48 and 48 3s are is 144. So the answer for LCM will be 144. Now children, let us see one more example of the number 2 and 5, and we will find its least common multiple by the method of common multiples that you have already learned. So first of all, I am going to write the multiples of 2, that are the table of 2. 2, 4, 6, 8, 10, 12 and so on. Then I am going to write the multiples of 5, that is the table of 5. We have 5, 10, 15, 20, 25 and so on. Now I am going to write the common multiples of 2 and 5, and here we see we have to find the least common multiple. Least means the smallest, and obviously the smallest multiple will be the first common multiple of both the numbers. And you see the least common multiple, that is the first common multiple of both the numbers here we can see is 10. So the LCM of the two given numbers, that is 2 and 5 is 10. But children, this information is regarding the usefulness of this method. This method is used or recommended only when there are very small numbers to be used. That is like here 2 and 5 are used here, so we can use this method. But it is recommended to use the prime factorization method that we have used in the previous examples to find the least common multiple. Now we can check example number 6. Herein we have to find the LCM of 12 and 18, but here I am going to use another method wherein we are going to use the prime factorization of the two given numbers separately. Now I am doing the prime factorization of 12 separately and 18 separately. 2 6s are, 2 3s are and 3 1s are. So the prime factorization of 12 is 2 into 2 into 3, and that is of 18. Let us check. 2 9s are, 3 3s are and 3 1s are. And the prime factorization of 18 is coming out to be 2 into 3 into 3. Now children, how to take the LCM in this case? We have to take all the prime factors which are appearing, that is 2 and 3, but the maximum number of times they are appearing. Like here in the prime factorization of 12, 2 is appearing 2 times and in 18 it is appearing only 1 time. But we have to take it the maximum number of times it is appearing, that is 2 into 2. And similarly in case of 3 is appearing in the prime factorization of 12 once, but in the prime factorization of 18 it is appearing twice. So we are going to take it as twice. So the LCM will be the multiplication. 2 into 2, 4, 4 3, 12 and 12 3 is 36. So this was a method wherein we have taken the prime factorization of the two numbers separately. So children, we have done 3 methods to find the least common multiple. First one is the prime factorization method. Second, we did for smaller numbers wherein we find the multiples and write down the first common multiple will be the LCM. And third method is finding the prime factorization separately and then taking all the prime factors together, but the maximum number of times they are appearing. Children, it is recommended to you to use the first method, that is of prime factorization taken together, because it is more convenient and easy method for better understanding. Thank you and have a nice day.